I just want to tell you a personal story. When I finished my training, I started working in research on beans. We realized very soon that the best beans for fixing nitrogen were the climbing beans. Because of my own interest for that long period of time, I'm really excited to be able to see what you're doing today and to see the climbing beans in your fields.
Ugereranyije n'ibyo mwahingaga kera ubu ngubu ibihingwa ubona byaje ari bishasha ni nkibihe urukubona bari guhinga bigezweho
nibi bitangiye kuza biraza by'iterambere
nkibihe
nibi bishimbo
climbing beans oha it's a modern crop.
I'm walking between two fields of climbing beans in northern Rwanda. Beans were introduced into Africa in the 16th century from Latin America, from South America, along with maize, and they've traveled together through Africa ever since. What you see here now, though, these climbing beans, were actually only found in a very few pockets in northern Rwanda and in DRC, but in the very highlands. Here we are around 2,000, 2,300 meters above sea level. We're very high up. That means that it's a cooler climate, and these beans actually take much longer to grow and develop than the bush beans. If we go back to the 1970s, what you'd have found here is 90% or more of the landscape would be covered with the bush beans, the short beans, and just a very, very few fields of climbing beans. In the 1970s, scientists from the National Research Station here, ISA, in Rwanda, started experimenting with some of the climbing bean varieties. And it was only really in the 1980s when they developed a partnership with CIAT, that's the research institute in Colombia in South America, that things really started to take off. They were able to introduce climbing beans from the Andes, from the high mountains in South America, which were much more vigorous, had many more different attributes, features, which were much better than the climbing beans that were found here. And through a series of breeding trials and then participatory breeding, so working together with the farmers to actually select varieties, they came up with a whole range of new climbing bean varieties which would actually give double the yield of these small bush beans. When these beans were then introduced, we got good varieties. The problems that farmers encountered were several-fold. The first one is, because these beans grow up to a large height, they take much longer to develop than the bush beans, about a month longer. The second point was you need to stake them. And there was a problem finding enough sticks and stakes to keep them elevated up into the air like this. And the third problem was they do need soils which are reasonably fertile on which to grow. Now, those problems have really all been overcome. Farmers started off using stakes, a whole variety of things. In this field we can see some maize stalks being used, some stalks of elephant grass, which is this grass actually growing along the border here, and also some woody twigs which are coming, some stakes which are coming from trees. Now there are two things I'd just like to show you here. First of all, we've got this terrace developing behind a boundary of elephant grass, this Pennisetum purpureum. This is cut for fodder, but it also allowed to grow through to actually produce stakes that the beans can grow on. On these steep landscapes in northern Rwanda, this grass elephant grass, or Pennisetum purpureum, has a number of different uses. It's cut when it's nice and green as fodder for the animals. It's really one of the main staking materials for the climbing beans. These long stems of Pennisetum are used for that. And the other important function is it forms these barriers which help to arrest soil erosion. So as the soil is being washed down and arrested, it builds up behind the grass strips and it's stopped from washing further down the slope. The other thing is this plant down here, this is a bit of a new test for this area because we've got a legume tree, a multi-purpose legume tree, which can also be cut for fodder or allowed to be going through to actually produce stakes like this for climbing beans. And that we find is already adopted in quite large areas. Once these problems have been solved, we found that the beans absolutely spread like wildfire from farmer to farmer through this area. So within a fairly short space of time, from around the mid-80s to the early 1990s, you went from having virtually no climbing beans in this area to having more than 90% of the farmers actually growing climbing beans.
Jean Damour, here we have a very nice example of how biological nitrogen fixation only works optimally when soils are managed well. The soils we have here in the region, they are not so poor, they are well structured, they have good water holding capacities, but they've been here for many years. A lot of the nutrients has been washed out. There's when nutrients are moving out, there's often some chance for acidification. So these soils have mediocre fertility. In this plot here, we have actually applied nutrients. We have applied TSP, which is phosphor, and KCl, which is potassium. And you look at this plant, it is growing relatively better than when you would not apply those nutrients, but the leaves are a little bit yellowish and the biomass is not all that impressive. Now, if we move to a plot close by, here we have the same variety, Gasilida, than we saw in the other plot, but it's very obvious that the leaves are greener, that the biomass is much higher, the plant is growing taller, and there are many more pods everywhere. Now, the difference is, here we have mixed the same fertilizer as in the other plot with organic matter. Organic matter usually is manure, you know, collected from the stables where the cows are, mixed with some household material, and put in the pockets at planting. And you also see that the biomass is higher, more bushy, with a lot more pods everywhere. Which means that the whole process of biological nitrogen fixation doesn't have any limitations anymore and can fix at its optimal rates. So in conclusion, if we really want to make biological nitrogen fixation work, we need to also take care of all the other soil constraints that may retard or delay biological nitrogen fixation.
Especially for growing beans, you need to have a cow in this land so that you find manure.
So here we've got a demonstration plot, essentially on some of these soils we were talking about earlier, which are really some of the very, very old soils in Africa, some of the oldest soils, which are basically completely exhausted in terms of their nutrients. What we see in the foreground in this plot very close to us is that without any additions, essentially these beans are yielding virtually nothing. So there's no mineral fertilizer, there's no local compost here at all. The farmers have guinea pigs and rabbits in this area. They collect their manure and they make a little compost of that, and just a teaspoon of that in a hole when the beans are planted actually can give you the difference between virtually no yield and a really good yield of 2 tons of beans or more.
This is the avenue of climbing beans. Climbing beans is a new technology in Kenya. As you can see, they are performing, but not really good like in some places in Africa, like the highlands of Rwanda. The reason that they are not performing well is that these materials were obtained in the highlands of Rwanda, where the area is on a high altitude, above 2,000 meters above sea level. And these materials are sensitive to temperatures. And that's why when they are grown on low altitudes, the performance is really not good. Apart from poor performance of the varieties, we have another problem, which is could hinder the adoption of this technology in Western Kenya, in particular the shortage of stakes. Climbing beans need stakes for them to be able to creep and produce good yields. Now in Western Kenya, there are a lot of shortage of stakes, and this could really hinder the adoption of this technology. But apart from the stakes, a few stakes that a farmer managed to get, they are also eaten by termites. With regard to the varieties, we are now discussing with the breeders to see if we can get good materials which are suited to this type of attitudes.
One of the innovations that can help overcome the problems of termites is, instead of having a bean climbing up a single pole, is to build a tripod. And if the termites eat the base of the sticks, then the whole thing doesn't collapse. We've got many, many different types of climbing bean. Some of these climbing beans can take a very, very long time to grow and yield. Other types of climbing bean are much shorter in terms of their growing season. I think at the moment, some of the varieties that we've brought have come from the highlands in Rwanda, where they're really very long seasons. But we've got new varieties which are actually more adapted to what we call mid-altitudes. And here we're at around 1,300 meters, 1,000, 1,300, 1,500 meters.
My concern is about the climbing bean. The life expectancy from planting to harvesting. You see the upper part is still flowering and the lower part has some pods. So it's not clear to the farmers how long the plant will take while on the field.
If the pods are ripening, you can actually pull the pods off the plant. And if you do that, that stimulates it to produce more flowers. So the plant will actually carry on producing more and more pods. Yeah? Now, of course, if the rains are ending, then the plant will dry and stop. But if you get late rains, you could leave the climbing beans in the field and they'll carry on growing. I'm nearly 2 meters tall, and I'm standing here in this plot of climbing beans, and just look at this luxuriant biomass. Because these plants can grow vertically like this, they intercept all of the light going all the way down to the floor, to the ground, so that they can fix a lot more carbon from the atmosphere in photosynthesis, and that gives us this energy source for fixing nitrogen. These beans are actually not inoculated. They're actually just using the bacteria, the rhizobia, that are indigenous to the soil, and it's giving us this wonderful result. So bean is one of the legumes which is actually very good at finding bacteria in the soil with which it can nodulate without inoculation. And as long as we make sure that the soil is well managed, so that all of the nutrients are available, then we can see that we can get this fantastic biomass, this fantastic amount of nitrogen.